For centuries, humans gazed up with eyes filled with wonder and questions. What lay beyond those glittering stars? Was there an edge to the cosmos, or did it go on forever? The sky, where the light we see and the stars we cherish, are only a glimpse of what truly exists. Beyond the vastness, hidden in the fabric of space itself, lie objects that defy everything we know. These invisible forces are so powerful that even light itself cannot escape their pull. These are the enigmas of the cosmos, where gravity's intense pull breaks down even the laws of physics and time itself stands still. This is the story of black holes, enigmatic giants lurking in the shadows of our universe. They are the ultimate cosmic mystery, where time and space bend beyond our understanding. Let's explore the ideas that hinted at their existence, the groundbreaking theories that shaped our understanding, and the scientists whose work pushed the boundaries of knowledge. In the late 18th century, John Michel proposed the idea of a dark star, a massive object with gravity strong enough to trap light. But the idea was too bold for its time. The world was not ready for such radical ideas. Things moved on, and Michel's dark star was forgotten with time. Then, over a century later, in 1915, Albert Einstein emerged with his revolutionary general theory of relativity. He changed how we viewed the cosmos and gravity. Einstein proposed that gravity wasn't just an invisible force pulling objects toward each other. It was a bending and warping of space-time itself. Imagine space as a massive, taut trampoline. If you place a heavy object in the center, it creates a dip, and smaller objects roll toward it naturally. As scientists looked closely at Einstein's ideas about how space and gravity work, a German physicist named Karl Schwarzschild made a startling discovery. In 1915, Schwarzschild realized that massive objects could warp space so much that nothing, not even light, could escape, leading to the concept of a black hole. Even though it was Einstein's own theory that led to this discovery by Schwarzschild, he himself found it hard to believe. It sounded too strange to Einstein, but as time went on, scientists found more and more clues, showing that these mysterious objects actually do exist. Though black holes were predicted by theory, they remained largely abstract mathematical concepts for decades. But as we entered the mid-20th century, new discoveries started turning these abstract ideas into something much more tangible. Then came S. Chandrasekhar, an Indian astrophysicist, who discovered that stars above a certain mass would collapse under their own gravity at the end of their life cycles, forming black holes. Chandrasekhar's findings strengthened the belief in something like a black hole. By the 1930s, scientists were beginning to understand that stars could collapse under their own gravity at the end of their life cycles. This led to the realization that black holes might not just be theoretical, they could actually form in nature. But it wasn't until the 1960s that direct evidence began to emerge, as astronomers discovered mysterious stars orbiting unseen companions with an intense gravitational pull. This was the first real glimpse of what could be actual black holes in the universe. In the 1960s, new observations revealed stars orbiting what appeared to be nothing. Astronomers realized these stars were interacting with invisible companions with an intense gravitational pull. John Wheeler, an American physicist, coined the term black hole to describe these unseen cosmic entities, transforming what was once a shadowy specter into a concrete object of study. Despite the wonders of Einstein's theories and decades of speculation, black holes remained hidden. It wasn't until technology caught up in the late 20th century that we began to truly search for evidence of these cosmic giants. By the 1990s, scientists had created complex simulations of what a black hole's surroundings might look like, showcasing a swirling ring of light around a dark center. But direct observation still eluded us, until one monumental discovery. In 2015, the Laser Interferometer Gravitational Wave Observatory detected ripples in spacetime by two black holes colliding. We had, for the first time, heard the sound of black holes merging from a collision billions of years ago. It was a cosmic whisper, confirming that black holes not only existed, but were active players in the universe's story. After that, the world was ready for more, and more was coming. Teams of scientists from across the globe embarked on a mission that sounded like pure fantasy. The mission to photograph a black hole. In 2017, they connected 8 powerful telescopes spread across Earth, creating a virtual dish the size of our planet. This array of telescopes was named the Event Horizon Telescope. They focused on Messier 87, a galaxy 55 million light-years away from us, harboring a supermassive black hole. The data collected was immense, and it took years of meticulous processing. Then, in April 2019, the first image of a black hole was unveiled. a ring of blazing light surrounding the pitch-black shadow of the event horizon. It felt as if we were staring into the eye of the cosmos. It was a defining moment, one that showed us not just the shadow of a black hole, but the remarkable power of human curiosity. The image of a black hole was more than just proof of its existence. It was a testament to humanity's unyielding quest to understand the unknown. Black holes are often portrayed in science fiction as cosmic vacuum cleaners, sucking up everything in their path. However, this is a misconception. Despite what movies show, black holes aren't cosmic vacuum cleaners sucking up everything around them. For example, in movies like Interstellar and Event Horizon, black holes are shown as monstrous forces that devour entire spaceships or planets. But in reality, black holes only affect objects that come too close to them specifically, once they cross the event horizon. Black holes do not wander through space randomly, devouring everything they encounter. They have gravitational pull, just like any other object with mass. If our sun were replaced by a black hole of the same mass, Earth's orbit would remain unchanged. We would not be sucked in. To understand what black holes are and how they're formed, we need to look at three basic things: mass, gravity, and stars. Mass is the amount of matter inside an object. It determines how much gravitational pull the object has. For example, a solid ball of iron has more mass than a hollow one, even if they're the same size. This is because it contains more matter. A larger mass means stronger gravity, which is why Earth's gravity is stronger than the Moon's. Gravity is directly proportional to mass of an object. Gravity is the force that pulls objects toward each other. The bigger the object, the stronger its gravitational pull. For instance, Earth's gravity keeps us grounded and makes objects fall. A more massive object, like a planet, has a stronger pull than a smaller one, like a rock, or Earth has a stronger gravitational force than the Moon. A star is essentially a huge ball of hot gas that shines by producing light and energy. During its life, a star stays stable because there's an outward pressure from the hot gases inside, balancing the gravitational force of its massive core, pulling everything inward. However, when a star starts to die and runs out of fuel, it can't maintain this balance anymore. Gravitational force takes over, pulling huge amounts of matter toward the core and packing it incredibly densely, while the outer layers of the star blow away in a massive explosion known as a supernova. This explosion scatters elements into space and can even form new stars. If the core left behind is massive enough, the collapse of the star doesn't stop. It continues indefinitely. This constant collapsing crushes the core and packs everything so densely into an infinitely small point, called a singularity. A singularity is essentially a point with infinite density, where all the matter from a star is crushed into an incredibly tiny space. It's like packing a mountain into a marble-sized space. The singularity lies at the heart of a black hole. It is a point of infinite density and zero volume. The singularity is surrounded by an event horizon. This is the point of no return. Once something crosses the event horizon, it can never escape the gravitational pull of the black hole. Think of the event horizon as a boundary around the black hole. It's like crossing the point of no return, like falling past the edge of a cliff. At this point, the gravitational force becomes so intense that not even light can escape its pull. Because light gets trapped inside and we can't see it, it is called a black hole. But not every star that dies becomes a black hole. Only stars with a core massive enough to reach singularity form black holes. Stars that aren't massive enough are either completely destroyed in the supernova explosion, or if they're of medium size, they end up as neutron stars. Neutron stars are incredibly dense and have very strong gravitational forces, but not strong enough to trap light, so they don't become black holes. Scientists mainly divide black holes into three categories based on their sizes. First one is stellar black holes. These are the most common types. Stellar black holes are typically between 3 and 10 times the mass of our sun. They're the normal black holes you might have heard about, created when stars go supernova and collapse under their own gravity. Next, we have intermediate black holes. These are the middle ground between stellar black holes and supermassive black holes. They can be hundreds to thousands of times the mass of the sun. While scientists have found evidence of stellar black holes, intermediate black holes are harder to detect. They're believed to form when multiple smaller black holes merge together, or when massive star clusters collapse. There are still many questions about how they form and how common they are in the universe. Finally, we have supermassive black holes, which are truly gigantic. These can be millions or even billions of times the mass of our sun. They're found at the center of almost every large galaxy, including our own Milky Way. It's thought that these supermassive black holes formed early in the universe's history and grew by pulling in gas, dust, and even merging with other black holes. We're not sure exactly how they form, but they play a huge role in how galaxies evolve, influencing the stars and even the shape of entire galaxies. Black holes do not emit light, hence their name. However, we can detect them indirectly. As matter falls into a black hole, it heats up and emits radiation. This radiation can be detected by telescopes. A black hole is just like any other object in space, like Jupiter or a star, except its gravity is so intense that it warps space itself, making it impossible for anything, not even light, to escape. But the amazing thing is that inside a black hole, the laws of physics as we know them seem to break down. We still don't fully understand what happens there. It's one of the biggest mysteries in the universe. What happens inside a black hole remains one of humanity's biggest mysteries. Our current understanding of physics breaks down at the singularity. We need new theories to describe the extreme conditions there. Some theories suggest that black holes could be gateways to other universes or dimensions. These ideas are highly speculative, but intriguing nonetheless. Scientists are now exploring concepts like Hawking radiation. Hawking radiation is the idea that black holes slowly lose particles, almost like they're leaking energy over time. This means that eventually they might disappear entirely. If this proves true, black holes could hold the key to unlocking the mysteries of quantum mechanics and even the beginning of our universe itself. As we push further into the cosmic dark, black holes continue to challenge our understanding and fuel our imagination. They are not just the monsters of our universe, but also the guardians of its most profound secrets. And perhaps one day, those secrets will tell us more about who we are, where we came from, and where we might be heading. In chasing these cosmic shadows, we reveal humanity's unyielding curiosity to confront the unknown. Could black holes be doorways to realms we can't yet fathom? Do you think we'll ever fully understand what's inside a black hole? Or will it remain an eternal mystery? Let us know your thoughts in the comments. Just as we once gazed into the skies with wonder, black holes still invite us to peer into the deepest mysteries of the universe with the same curiosity to unlock its secrets.